In this example, we'll look at how to use a matrix to represent connections. So for this example, the network diagram, it shows that there are the different ways that you can travel between three towns A, B, and C. So what you've got to do is you have to use a matrix to represent the connections. Each element should describe the number of ways to travel directly from one town to the other. So what we need to remember is it's talking about that how many ways can you travel from one town to the other directly. And then what information is given by the sum of the second column of the matrix. Okay, so since there are three matrices, let's use a 3 by 3. Since there are three towns, let's use a 3 by 3 matrix. So we use a 3 by 3 matrix to represent this information. Okay, which means that we have town A, B, and C. Let's just redo that. Town A, B, and C. And we have town A, B, and C. Now, because obviously we can't go from town A to town A, or town B to town B, or town C to town C, those three matrices will have no direct path. So therefore, A to A, so A to A will be a 0, B to B will be a 0, and C to C will be a 0. Now, let's have a look at the three different towns. And let's have a look at from A to B. So that's the next thing. From A to B, there's a direct path. There's one direct path from A to B. So therefore, we write down 1. From A to C. So from A to C, how many direct paths are there? There isn't any direct path from A to C. So therefore, that will be a 0. Let's look at B. Okay. So from B to A. Now, because there's no arrows, so therefore it doesn't mean that it's only in one direction. So from B to A, there's one direct path. B to C, from B to C, you can either go that way or you can go that way. So there's 2. So you write down 2. Let's go to C. C to A, there's no direct path from C to A, so therefore that's a 0. So if you notice, A to C and C to A, they both would have the same value as their element. And then from C to B, you can either go that way or that way, which gives us 2. And likewise, if you have a look, either it's from B to C or from C to B, the values of the elements are the same. So this matrix represents the number of paths that are directly connected between the towns A, B, and C. Okay, now let's have a look at question B. Question B says, so this is question A. Question B is asking us, what information is given by the sum of the second column of the matrix? So the second column of the matrix is over here. Okay, and that relates to town B. So that means that all the elements in that second column, okay, so the second column relates to town B. And it talks about all the different ways. So the elements are 1 plus 0 plus 2, which gives us 3. So basically, what that means is there are 3 paths directly connected to town B. So basically, there's 3 different roads to town B. That's one road, that's another road, and that's another road. So if you have a look, there are 3 different roads connected to town B. Now, on the flip side, we could also draw a network diagram when a matrix is given. So for this example, the matrix over there is given to show the direct routes between 4 towns, T, U, V, and W. What we need to do is to draw a network diagram using the given information, so using that information. Now let's interpret the matrix. As you can see that there are 4 towns, T, U, V, W, okay? So obviously there's no direct road linked between T to T, or U to U, or V to V, or W to W. But if you read across, so T has got a direct route to town U, and T also has got a direct route or a direct road to town W. U has got a direct road to town T, as we have seen in the first row. V now also has a direct road to town W. And if you go to W, obviously, because it has a direct route to T and V, that's where we should have a 1. So let's draw this. So obviously we'll have 4 different towns. So let's draw our 4 different towns. So I'm going to just write down, start with town T. So I'll just draw a T. Okay, and maybe a dot over there. And it has a direct route to town U. So I can do a U over here. So this is town U. Now to show that they have a road between them, obviously you can draw a line. So that is to do T to U, which is that one, or U to T, which is that one. Okay. The next one, which is T to W, T also has got a direct route to town W. So we can put it anywhere, maybe W can be there. And let's use a different color. It can be a straight line or just a curve. So there's a road between town T and W. So between town T and W, which is that one. And obviously from W to T, which is that one. Okay, let's go to the next one. So we've encountered U, we have accounted for U and T. Let's go to V. Now V has a road from itself to town W only. So that means from W can only go to, there can only be a road from V to only W. Let's do a different color, which means that V to W accounts for that, and likewise W to V is that one. So if we have a look, wherever there's a 1 that matches to a line, and all we've done now, it doesn't have to look this way. You might position your 4 towns in a different way, and that's okay, as long as you show that they are connected and there's a direct road, or there's a direct link between those 4 different towns. Okay, the next thing that we're going to look at is power matrices. So when towns do not have a direct route connecting them, that means you can go to each of the towns via another town. So that means there's like a stopover. When you go from one place, from one city to another, you stop over in another city, and then you might change planes, for example, and then fly to another place. When that happens, that's where power matrices are used. So a power matrix of C squared would show that you can travel from between 2 towns with 1 stopover. So you go from one town to another town, but it has to go via one other town. If it's C cubed, then that will be via 2 other towns. So you get to 3 towns, then you go via 2 other towns. Now to do that, you actually have to get the result of C squared, or the power matrix, or whichever the matrix is, you have to square it. For this example, where this matrix represents direct air routes between Mount Isa, M, Rockhampton, R, and C, which is Cairns. Okay, so the first thing we need to do is to calculate matrix C squared. Now to do that, you just basically calculate C squared, which means you multiply the 2 matrices by itself. So the matrix 0, 1, and 0, 1, 0. Multiply that by itself. So 0, 1, 0, 1, 0, 1, and 0, 1, 0. Now we've done multiplication of matrices. And if you multiply this out, what you would get is 1, 0, 1, 0, 2, 0, and 1, 0, 1. So that is the matrix C squared. Okay, so that's the first thing. You calculate the matrix C squared. Then the second question is asking what is represented by the element C13. So if I go to identify that, so 13 means it's in row 1 and column 3. Okay, now if I just write down that these are between the three towns M, R, C over there and M, R, C over here. So we go to row 1, column 3, which is that. So let's just write that down. The element at that position is 1. And if you have a look, it is talking about the route between M and C, so which is Mount Isa and Cairns. Okay, so what that means, that there is one route between Mount Isa and Cairns with one stopover.